So we're going to look at 4.6, and what 4.6 is special products, and so more multiplying, and so that's our plan. Let's check it out. It's not so bad. And so they give you some formulas. They say that you can use instead of using FOIL on certain things, and so this is one of the formulas that they give. They say that you can, and I'm going to show you how to use the formula, and I'm going to give you the choice. So they say this is equal to that, and this is equal to that. Well, it's not very hard to show that this is equal to that. I'll come over here and we'll do it. And so what it means to square is it means to write the base twice, and then multiply normally. And well, a binomial times a binomial normally is FOIL, right? So this is a to the first times a to the first. That's a to the second, right? Add the exponents when you have a variable, even if it's capital. So a to the second. And then a times b, remember alphabetical order, so plus ab. That's 1ab, right? And then here, when you multiply those together, I know you're thinking BA, but it's not BA, alphabetical order, it's AB, 1AB, another one, right? And last but not least, in our FOIL, B times B, B to the first times B to the first is B to the second. Add the exponents. Then you want to combine like terms, and this is 1AB plus 1AB, which is 2AB. A squared plus 2AB plus B squared. And you see, that's the formula, right? So you can, when you get a problem like this, you can use the formula, and we'll practice that, or you can just write it twice and use FOIL. And so me, I don't, I'm like, well, I'll just write it twice and use FOIL is what I would do. So this is the formula if it's minus, right? And I'm going to show you that that is the formula by using FOIL. So a to the 1 times a to the 1 is a to the second. A positive times a negative is a negative, AB, alphabetical order. I wonder if Cold Stones is still open. What time is it? Oh, no, probably not. I wonder what I have that I can have at my own house. So negative times a positive is a negative, and then AB, alphabetical order. And then a negative times a negative is a positive, B times B, B to the first times B to the first, add the exponents, B to the second, right? And then combining like terms, remember this is 1AB and 1AB. The reason I want to put the ones there is because when they're like terms, you add the number part. Well, what's the number? It's 1, negative 1, in fact. So negative 1 and negative 1 is negative 2. So this is a squared minus 2ab. Attach the same variable plus b squared. And you notice, oh, that's just that. Okay, so I can't help, but so here's this problem here, 5x plus y, quantity squared. And so I can't help but do it two ways. So if you did the formula, so by the formula method. So how you do it with the formula is that you write out the formula. This is plus, so I want to use this formula. So you have this formula memorized. So if you're already like, I don't memorize things, well, okay, then the formula might not be for you. And then right below it, I'm going to put what we're trying to multiply out. And everywhere you see A, you're going to put 5x. So everywhere you see A, you're going to put 5x. And everywhere you see B, you're going to put y. So you're going to be filling in the blanks right here. Everywhere you see A, you're going to put 5x, right? Those are the places where A was. So I'm going to put right in there 5x. and write in here 5x. And everywhere I see b, I'm going to put y. And then all you have to do is put it together. So this is 5x squared is 5x times 5x, which is 25x squared. That's the product to a power rule. 5 to the second is 25. X to the second, x squared. Or the definition, 5x times 5x is 25x squared. Then multiplying these together, you multiply the numbers, 10, and the variables in alphabetical order, and then y squared. So that's the formula method in all its glory. And now we'll do the FOIL method. And sometimes I wonder, why didn't I have more room? So the FOIL method says write the base twice. So 5, and then FOIL. 5x times 5x is 25x squared. Right? Do the numbers together and add the exponents. Then 5x times a positive is positive, and that's 5xy, alphabetical order. And then on the inside, I'm going to have a positive times a positive is a positive. Numbers first, alphabetical order, 5xy. And then last, y times y is positive times a positive, that's y squared. And then all you have to do is combine like terms. When I combine like terms, 5xy plus 5xy is 10xy. So you get the same answer whether you use FOIL or you use the formula. And so in about the same amount of room, I had a squish here, and I was more, I probably should have gone up here a little higher and then whatever have you. So, but I mean, about the same amount of work. Usually I just would think that. I wouldn't write it. But when you first start, you are writing it, I think. Okay. Now, it wouldn't be appropriate to use the formula for this because this is not what the formula goes with. The formula goes with something squared is what the formula goes for. So the formula doesn't go with something like this, right? And so the formula goes with when I have a binomial squared, or I have a binomial that's a subtraction, right, squared. But this is a binomial times a binomial, and they're not exactly the same. So when I FOIL this together, I get here 3x times 3x is 9x squared. And then I get negative, right? A positive times a negative, and 5 times 3 is 15x plus 15x. Negative times a negative is a positive times a negative is a negative 25. And then the center makes 0, right? So I get 9x squared minus 25. And we talked about this one in 4.5, I believe it was 4.5, that it's called the difference of squares. And the reason it's called the difference of squares is because this is a minus. And that's a perfect square. 9 is a perfect square. What makes something a perfect square is that it can be written as a multiply by itself. And 9 is 3 times 3. So that's what makes it a perfect square. Whereas 8 isn't a perfect square because you can't write using whole numbers two things together that equal 8 that are using whole numbers again, that are equal to one another. Like you could do 2 times 4 to make 8. But 9, why it's special in a perfect square is because it's 3 times 3, and these are the same. And so that's what makes it a square. And x squared, well, that's x times x, right? They're the same. And 25, well, that's 5 times 5. And so it's a difference of squares. DOS is what it is. Okay. And so you might be noticing that when you multiply something like this together, that the outer and the inner are going to drop out. The minute that you realize that the first, the outer, the inner, the last, that the first, outer, inner, last, the minute that you realize that these are going to make 0, and you can predict when they're going to make 0, then you don't have to multiply them together. And that's one of the things they show you in the book, because this was special factoring. And so, or special factoring, special products, special multiplying, is that, hey, that if you're going to get this, you might as well only do the first and the last, since the outer and the inner are going to make 0. And I'm good with that, if you like. And in fact, I'll do it on the next one. I'll use that. So should I use the formula? It's almost the same as that one. I noticed that example. It's like, whoa, I should have changed that to a 3 or something, but I didn't. So do it however you like, right? If you like to multiply this together by doing FOIL, that's great. If you're liking to use the formula, that's great too. So first is 25x squared. 5 times 1 is 5x plus 5x plus 1. So this thing is 25x squared plus 10x plus 1. And minus, right? And then here's where you have to be careful, is that right now, the way this is written, I have parentheses there, but this is saying minus whatever you have here. And when I FOIL this together, but do you guys notice that this one, when I FOIL it, the outer and the inner are going to make 0, right? It's that special thing. See how it's a plus and a minus, but are the same thing? Well, that's what's going to happen here, right? And so, but I need to distribute that minus. And I'm going to end up with a binomial. I'm going to have a first and I'm going to have the last. X times x is x squared. There's the first. And then minus 2 times 2 is 4. There's the last. So then I'm going to need to distribute this minus here. So I'm going to have here negative x squared and plus 4. And then now I'm ready to combine like terms. 25x squared, take away 1x squared. Ooh, I wish I had some water. Oh, I do. I don't know. Maybe my cats drank out of this. I'm not sure. Plus 10x, and then plus 5. So we did these before in the last section, and you wouldn't be able to predict what it's going to turn out to be, but they're going to call it a special name here. And so, but how we learn to multiply these together, use the distributive property, the pattern of FOIL. It's not exactly FOIL because it's a trinomial, but I remember that one of my students called it FOIL, and another teacher was there, and they corrected them, and I thought, well, FOIL is a pattern, and I kind of agree with them. You know, that it's a pattern. You multiply this, right? So that's x to the third. X times x to the second, right? 1x, 2 more x's, because that's what x to the second means. It means x times x. Makes 3 of them all together, right? You get your fingers out at any time. And so plus, and then 5x squared, because I have x and I have another x, that's x to the second, right? So here. And then I have plus 25x. So there's my first pass. And then I'm going to do the inside. And I a lot of times like to stack them up like a Wendy's double stack, because a lot of times when they're in descending order like this, that they're going to be just like terms. So here's minus 5x squared. And they're really like terms. They're the same. That, I was saying like terms, but they're like, really like, right? And then here, and we get minus, is that 125? 5 times 25, 125. And then when you clear this, the outer and the inner here, the whole inners become 0, and I get x to the third minus 125. And they call that a difference of cubes. And the reason it's a cube is that when you multiply it together, you get, there is a number that when I multiply it by itself 3 times, it equals 125. And that number's 5. 5 times 5 times 5 is 125. And you can write this as 5 to the third. That's why it's called a cube. And that's 125. So 125 is a perfect cube. X to the third is a perfect cube too, because, well, x to the third is x times x times x, right? Now, I had given you the example up here, and I said 8 is not a perfect square because there isn't whole numbers that when you multiply it times itself that you get 8. Just two of them though, right? 9 was 3 times 3, but 8 wasn't. But look how 8 is a cube, right? 2 times 2 times 2. So 8 is special because it's a cube. Anyway, that's that story there. We're going to be looking at these a lot coming up. And we want to be able to identify them. And so that's the reason that they start giving you foreshadowing. They start showing you. So they don't just do foreshadowing and, the scary music when you're in the movie theater. They also do it in math. And so this is a common boo-boo to avoid. The most common boo-boo when someone has a plus b squared, quantity squared, is to say that that's a squared plus b squared. It's not. It is really a plus b squared is really a squared plus 2ab plus b squared. And remember, we did that, right? Right here. So if you're remembering, yeah, we did that, right? So that's what it really is. So it's not this. So this is don't do it, is what this is saying. So these are boo-boos to avoid. Don't do this. It is really common for people to do that. And this one, remember what it is really. Right? Okay. Now, the reason that you might have thought it okay, I just want to show you why you might have thought it okay, is that the product to a power rule, AB raised to the second, this is multiply in between, as opposed to this being add in between the A and the B, and subtract in between the A and the B. It doesn't matter if you use capital either, it's the same, right? AB squared like this with capital would be A squared B squared, like that. So it doesn't matter if it's capital or lowercase. It's just they use lowercase for these rules and they use uppercase for these rules. So I just kind of kept the same convention, but it doesn't matter at all. And this is fine and it's okay. And the difference is that this is freaking times, right? And this is add. And this is subtract, right? That's the difference. And so, and it was okay with division as well. That AB squared, this is A squared, B squared. And so the difference is, so you're just applying it to the pieces when it's multiply and divide, right? But something else happens, you have to FOIL when you have a binomial. So it's also that this is multiply, but it's also size. This is a monomial squared, right? This is a binomial squared, so it's different. And this is a monomial because monomials are held together with multiplication and division, right? Where you get a binomial if you have add or subtract. Anyway, so that's kind of the story on that. And that's that section, whatever it is, 4-point special products, right? 4.6. And so we did a lovely job on it. Okay. Beautiful.